Hello, everyone. Welcome to your Algebra 1 homework. I hope you had a great afternoon and now you are enjoying your time learning some more algebra. I struggled with what I was going to go over today, but I'm just going for it. I'm teaching something that I'd hoped to get to in class and didn't, so we're just going to do it for homework. This was a particular problem that we left off with in class. We did look to see, because it is in the form of ax squared plus bx plus c, we tried to factor this polynomial, but they add to give you -5 and they multiply to give you 2. Well, that doesn't work. There is nothing that multiplies to give you 2 that is going to add to give you -5. So what we are going to have to do is look at our graph. If we can't factor it and set those two factors equal to 0, then we do have to look at our graph. Well, we did look at our graph in class, and if you remember, if this is 1, 2, 3, 4, 5, if we look at our graph of 2x squared minus 5x plus 1, we actually had a 0 kind of right here and another one about right here, and our parabola came down like this because you see that it has a y-intercept at 1, because right here's my y-intercept at +1. So we're looking at having two non-perfect numbers. I call them perfect numbers, but I should say they are not whole numbers. They are decimals. And so we can look at our graph and use our calculator to find these. But there is one more way that we did not talk about in class today that you can find your zeros. And it always, always, always works. It's called the quadratic formula. The quadratic formula will give you your roots, zeros, x-intercepts, or solutions. All four of these are the exact same thing. Any of these words are talking or speaking of the same thing. It's where you cross the x-axis. So the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now, if you plug in to this particular formula and simplify, you will get your roots. The reason you get decimals for some of these particular functions is because of that square root that's in there. Anytime you have the square root of a number that's not a perfect square, you're going to get a crazy decimal. And if you remember, those numbers are called irrational. So we have irrational numbers possible here. Now, I didn't get to sing in class today, so at least I get to sing for homework. There is a way for you to remember the quadratic formula, and a lot of my students liked this last year. Here I go. I don't want to sing on YouTube, but I guess it's going to happen. The quadratic formula is often called -b plus or minus root of b squared minus 4ac of b squared minus 4ac all over 2a, all over 2a. I won't scare you and sing again, but you can rewind your video over and over if you really want to hear me sing. But the way this works is, let's rewrite our equation. Y equals 2x squared minus 5x plus 1. I know that my a is 2, my b is negative 5, and my c is 1. I can determine my roots by saying negative b plus or minus root of b squared minus 4ac of b squared minus 4ac all over 2a, all over 2a. So we plug in a negative 5 plus or minus the square root of negative 5 squared minus 4 times 2 times 1, because this is my a, this is my b squared minus 4ac all over 2 times 2. Well, a negative makes a positive 5. We've got plus or minus the square root. Negative 5 squared is 25. And then minus 4 times 2 times 1, which is 8. All over 2a, so that gives us all over 4. Now, we can simplify under our radical a little more, and 25 minus 8 is going to give us 17. So we have 5 plus or minus the square root of 17 over 4. And this is where we know that we have 2 roots because it crossed twice, and that's where the plus or minus comes in. We have 5 plus the square root of 17 over 4, and we have to simplify. We've got to use parentheses here, ladies and gentlemen. We're going to get an answer for that, and then 5 minus the square root of 17, and then all over 4. If I plug in 5 plus the square root of 17, and then divide by 4, that's where my 2.2 comes from, 2.281. We found that with your calculator. And the other one is 5 minus the square root of 17, and then divided by 4. That's where our 0.219. So x can equal these two numbers, or if we want to write our x coordinates, remember we would write in this case we would write 2.281 comma 0 and 0.219 comma 0. So here are my coordinates. Always works. Always, always, always works. Now, if I were to give you y equals x squared plus 4x plus 4, if you wanted to try to factor, one option is to try to factor. We can say what two numbers add to give me 4 and multiply to give me 4. Well, obviously those are going to be 2 and 2. I can factor so that I have x squared plus 2x plus 2x plus 4. And if you remember what I said in class today, you could just say x plus 2 and x plus 2, but I'm not I'm hoping that some of us are going to pick up on that. It only works when our a is equal to 1. And so when I factor out my greatest common factor of x, I'm left with x plus 2. And when I factor out my greatest common factor of 2, I'm left with x plus 2. And then that leaves me with x plus 2 equals 0 and x plus 2 equals 0. Well, when you subtract 2 from both sides, they're the same. So you get x equal to negative 2. With that being said, my x-intercept is negative 2, 0. All of you can put this in your calculator. We can factor. Sometimes factoring doesn't work. The calculator always works. So you can take a look at your calculator. You should see your x and y axis, and that parabola should come down and bounce at negative 2 and then go back up so that you have an x-intercept at negative 2. And the third thing is your quadratic equation. Factors number 1, calculators number 2. Third is quadratic equation. Negative b, plus or minus root of b squared minus 4ac of b squared minus 4ac all over 2a, all over 2a. Well, my a is equal to 1. Coming back up here looking at my original, my b is equal to 4, and my c is equal to 4. So when I plug in, I get negative 4 plus or minus b squared, which is 4 squared, minus 4 times 1 times 4, all over 2a, or 2 times 1. Well, that gives me negative 4 plus or minus 4 squared is 16, and then minus 4 times 1 times 4 gives me 16 all over 2. Well, what happens is 16 minus 16 is 0. Anytime you have just one root where that parabola comes down and bounces and goes back up, then you're going to get a 0 under your radical because there's no plus or minus. You don't have to add or subtract anything. You just end up with negative 4 over 2, which equals negative 2. That's what we said. Highlight it real big. My answer is negative 2, 0. Well, I really don't have a lot of time to do another problem. So what I'm going to throw in real fast is if our picture looks like this, and we've got a x-intercept of negative 2, 0, my y-intercept, I think I did those in purple. My wrong thing. Our y-intercept is going to be 0, comma what? 4. And looking at our graph on our calculator, that x-intercept is also my lowest point. So my vertex is my minimum, which is still at negative 2, 0. And if my vertex is at negative 2, 0, my axis of symmetry is at x equals negative 2. I hope you have a great evening, ladies and gentlemen. I will see you tomorrow.